quiz. Doable. Okay. So what I decided is that I want to use the next 45 minutes to help you prepare for the exam. We'll do the Monte Carlo simulation exercise when we come back from the break and after the exam. Okay, so it's not due until October 30th. So let's worry about the exam first. Okay. So I want to bring to your attention several examples that I have made available in various places in my folders so that you actually do the practice. But before that, can we quickly go over the solution to this quiz? Right? So problem 1. The clean room has a dust concentration of 1.0 particles per centimeter cube. Okay, and we are sampling 2 centimeter cube of air. So it's not said, but we just assume that the number of particles is very low. That we don't assume, that is already evident. It's just 1 particle in a centimeter cube. To give you some perspective, this room right here has about 10,000 particles per centimeter cube. That's normal air, and this is clean room air, very clean. Particle is very low. So the probability of particles occurring in a sampled volume of gas, is rare. So we model that as a Poisson distribution. You don't have to write this, but this is for your understanding, I'm saying. So if it's a Poisson distribution, the probability of getting n particles in a volume is e power minus lambda power n divided by n factorial, where lambda is the mean or average parameter. And since we are told that the concentration is 1 per centimeter cube, and we are sampling 2 centimeter cube of air, so this is 2.0. So we have to compute what is the probability of n greater than or equal to 3 with this distribution. Okay. This is like saying probability of 3 plus probability of 4 plus and so on up to infinity. Like this is basically writing summation n equals 3 to infinity p of n. This is nothing but 1 minus p of 0 minus p of 1 minus p of 2. So what is p of 0? P of 0 would be e power minus lambda. P of 1 would be lambda e power minus lambda. P of 2 would be lambda squared e power minus lambda over 2. So you need to plug in lambda equals 2 and get these numbers and put them back here. I glanced over a few of the sheets. I don't want to pick specific sheets, that will be like identifying students, but what values did you all get for the final probability?
36.
36%. Did anyone else? Sorry?
This way, right? 36 something.
36 something. Anyone else? 32. Okay. 32 probably is what I recall when I did the problem, but here is the solution. Okay. So something for you to learn from here if you didn't already get it right. Second problem, for a random variable which is positive. Okay. It's told that x is a positive random variable and has a mean of 10 and a variance of 1.21, which is like saying standard deviation of 1.1. Compute the following probabilities. Probability of 0 less than x less than 12. Right, that is what is asked. 0 less than x less than 12. Okay. Now remember, x is not it is not the standard normal distribution. Mean is not 0. Standard deviation is not 1. So you have to effect a change in variables. So we'll do 3 equals x minus mu divided by sigma. So if we write x and z, if x is 0 and then x is 12. So what is 12 minus 10 divided by 1.1, which is 2 divided by 1.1, 1.81. Okay, and then this fact here has a little bit of relevance. X can only be positive according to this restriction. Okay, so if you draw the curve, this is like writing here is 10. Okay, so here is the normal distribution. The probability density function is split as 0 for x less than 0 and 1 over sigma square root of 2 pi exponent of minus 1 half x minus mu divided by sigma whole squared for x greater than or equal to 0. Okay, so if we want to write what is 0 here, 0 minus 10 divided by 1.1. What is minus 10 divided by 1.1? Negative 9.09. Okay, so when you are shifting this distribution, you're going to have 0. Okay, going to have 0. The shape of the distribution, if it looks like this, below 9.09, that is from 9.09 to the leftwards, this distribution does not exist, it just drops to 0. And we are asked to calculate what is minus 9.09 to plus 1.81. So for the normal distribution, you know that if x becomes very large, this minus 9.09 is practically equal to minus infinity. So this whole area more or less adds up to 0.5. And the other part here, you look up your table, 1.81 was 4649. No, 4649. So this is 0.4649. So the answer you want to be getting is probability of 0 less than x less than 12 is approximately equal to probability of minus 9.09 less than z less than 1.81, which is f of 1.81 plus f of 9.09, which is 0.4649 plus 0.5 0.9649. Yeah.
I solved it and I got 1.82. But it's.
This one,
Yes.
that's fine. If your procedure is fine, it won't be a problem. Okay. So this is 96 or 0.9649. The other part is real simple. The other part is basically probability of mu minus 3 halves sigma less than x less than mu plus 3 halves sigma. This is essentially minus 1.5 to plus 1.5 of z, or this is 2 times probability of z up to 1.5, which you can look up 2 times what? 433. Okay. 2 times 0.4332 or 0.8664. Okay, so this is your quiz. All right. So is anybody writing? We okay? So I don't want to go through entire problems in this session. I just want to give you like a starting point and then let you finish it. Okay? Yes. That's a typo. When I was writing the solution, I thought I'll change the question, but I forgot to update the first part. That is my mistake, but it's 11. Yeah, I'll repost that file. Okay. Okay, so I have some not announcements, like some information to share with you. Okay. So this is your syllabus. Okay, view bit. Okay. So today we are taking the quiz, and I was going to also do the homework 3 Monte Carlo exercise, but I figured that this is sort of not necessary today because exam is coming up. We'll do it after the exam, but I also changed the problem to something for which you have the answer or have a reference. So if you go to the handout, see example 4.14. I want you to implement that as a MATLAB code. It's a much simpler problem, just one quantity being simulated as a random number, much simpler than doing 7 swing states. Okay. But we'll discuss the swing states thing just not as a submission exercise. Okay. So you can get started on this. You already know enough information to solve the problem, and it's going to be due by October 30th. So that's 20 days time for you to do it. I think you'll all be able to do that. I don't know how many of you saw my email last evening. I added these notes saying these are additional examples you can find, which I discussed in actually last fall when I taught the course. There were like 35, 40 students. We did as many as like 10 additional sessions, like 10 1-hour sessions in addition to the regular contact hours. So we generated a lot of content back then. So if you go through some of these, you'll be able to get more examples to try, like step by step that I've explained. So this, as I complete each module, I'll try to find the relevant videos for you to see and post the link like this. I suggest you try these. Okay. So coming to exam 1, we are going to have 3 problems for 60 minutes, about the same ratio of time you're going on so far. These are the topics that will be covered in the exam. Now, for each module, I've given like 3 topics: Newton-Raphson, secant, bisection method. And what my hope is, by the end of this course, at least you'll be familiar with these. And if you want, you can learn more. You should be able to make the bridge. Okay. So, what I suggest you, or how you should prepare for this is, each topic that I list here, you should at least try 5 or 6 examples. That is the rule of thumb I'm giving you. So if you select a nonlinear equation, try solving the same equation using all 3 methods and get practice. So that see if you can finish approximately within 20 minutes. Okay. The second module is actually really simple. You will be definitely be able to finish a problem within 20 minutes. It's really like 3 equations, 3 unknowns, nothing fancy there. Okay. Third module, there is going to be only one question, and I can pretty much tell you that that question will be based on t statistic and confidence interval. It will still involve concepts of normal distribution or maybe Poisson distribution. I can work those in, but it will primarily be a question based on what we discussed in the last lecture. Because in the quiz, I didn't cover that. Of course, I'm going to cover that in the exam. So I'm telling you upfront. Okay. All right. So that said, if you also go towards the top of the table, there is course materials from fall 23 and fall 2019. Okay, so if I go to fall 23, what I will suggest you to do is to look at these exams and final, and whichever has questions which are relevant to you, I will ask you to, I would suggest you to practice. Like for example, if you took exam 3, okay, let's look at this file. Don't worry about the topics which you haven't yet seen. Like for example, this is coming up in module 5, so or module 6. So don't worry about this. What you should worry about is this problem here. Standard error estimate using students t distribution. So let's actually try this problem. So let me open this. Can I download this? Yeah. Okay. So here is the problem. We are going to attempt this now. The following data was collected by measuring the force load acting on a small area of a beam under repeated fixed conditions. So they are all part of the same experiment. There are 10 readings with outputs given to you. Calculate the following. State the formula used in each case. I mean, the reason this is written here is because this is the solutions part. In the actual exam, it will just be sample mean. Nobody will tell you this formula. You are supposed to know that. Okay. So can you go ahead and get the mean and standard deviation? If your calculator can do it, that's fine. You can also do it manually, whichever you prefer. It's a very typical question that can be asked to calculate confidence interval and using the t statistic for that, t statistic table for that. All right. Anyone has a value? Do you have a value for the mean? 923.7. Okay, let me write that down. 923.7. And the main thing is, if you know the standard deviation, which you can easily calculate as the next step, you should be trained to read the t statistic and divide by the square root of n. So you have 10 observations. So let's say we have the the standard deviation known, the t statistic looked up, divided by square root of 10. So if I am going to provide you this handout, I want you to read out what is the t statistic for 10 measurements. The t statistic for 10 measurements. For 10 measurements, the degrees of freedom is n minus 1, which is 9, and our confidence level is 95%. So you need to look for nu equal to 9 and t 95, which would be 2.262. The really straight arrow question. If you are able to read this chart, you're done. Okay? 2.262. Okay, so hopefully that was clear. Can I move forward? Is it okay? Right. The last question is the question that many students kind of didn't answer clearly. How would you state the true value of the reading at 95% confidence? What is true value? You're getting a sample mean and you're getting a sample standard deviation. What is the true value? You're going to write that?
Yeah.
You'll not get any score. Anyone else wants to try? That is part 3 or part C. So you got the sample mean, you got the confidence interval. True value is stating them together. It is one sentence saying the true value of the reading at 95% confidence is x bar plus or minus ci. That's it. It's the implication is the true value can be found, is likely to be found in the interval x plus or minus ci with 95% confidence. If you had used a different confidence level in your third step, then you will get a different range, but the idea of finding the true value remains the same. Okay, so the one sentence you need to write here is, let me write it. So x true, or if you want to call it true value, that's fine, is likely to be found in the interval x plus minus ci at 95% confidence. That's it. You can write this in many ways, but all I'm looking for is that you can put the sample mean and the confidence interval together to form an interval. That is what I'm looking for. So you have x bar, which is the sample mean, and this is minus ci, or x bar minus ci, and this is x bar plus ci. This is what we also discussed last lecture. If you make more observations, if you make like 100 observations or 1,000 observations, you can make the CI arbitrarily small so that the confidence on your mean increases. And this is also my example. You did 4 measurements, you did 20 measurements. I'm going to trust that value more than the set of 4. Okay. Any questions? Is it like too redundant? You have already seen all this. You don't want to be here. Sometimes hard to read your faces. Okay. All right. So let me see if what I want you to do is look through these exams and see if there is anything that you could use to practice. Okay. So, okay, here is a problem. Gaussian distribution for a variable z following standard normal distribution. Estimate c in each case. What is the value of c which contains up to 95% probability? You have your sheets with you, right? You could answer that even now. So it's like asking what value of c which is going to contain 95% of all the area. How will you answer this? Yeah. So you need to solve for C. What value of C will get you a 95% probability? So if I write minus Z less than C, sorry, minus infinity to C, this is minus infinity, let's say, and let's say here is Z equal to 0. Okay, here is the bell curve. First tell me, is C going to be here or C going to be here? Which mean you can draw it either way. You can draw it to the left or to the right of 0. What is the correct way to represent the value of C?
On the right.
The one on the right, because
Positive.
I mean, which is positive?
C is
Where
positive.
who said C is positive? Where is it
It's
said
positive compared to where C is 0. You say
There is another way of stating that. You should think in terms of the probability value. Do you want to try? Okay, go ahead.
well, I mean, I know what the Z is. It's 1.645.
That you know now, but how do you know to look in that table? Like when you see, this is not from 0 to C. This is minus infinity to C. So I could even draw this here. Why am I right in drawing it here? Yeah. Which is more than 50%. You know that half the area is 50%, right? Suppose I had written instead of 95%, suppose the question was 40%. Suppose the question is 40%, then this will be the correct way of drawing C. Because 40% is less than half. That is what I asked, how do you know? Or you know now because intuitively you saw 95, it's more than half, so you went for the right side. Okay. All right. So if it is 95%, if the left half is entirely 50%, then the right half is 45%. So if it's 45%, what value of C corresponds to 0.45? $1.645. Are we all together? Yeah? You're okay? 1.645. So the answer to this is 1.645. What about 5%? See, this is the other case I mentioned. This case, C is going to be here. 5%. What is the value of C? Oh, I hate this when they do it during class time. Okay, what is the value of C which gets you 5% when integrated from minus infinity to C? Sorry? Same? No, wrong. 0.0. Come again?
0.0987.
0.0987. No.
Before you do 95% divided by 2.
Remember, we are not asking you for probability. We are asking you for what value of C or what value of Z will give you 5% probability. It's the other way, inverse.
0.07.
Point
0.065.
0.065. No, wrong.
0.1736.
0.1736. No, where are you getting that from?
I just did it wrong. 50%.
So far I have not had any correct answer. 0.06. No, wrong again. I should put this on the test. Start from the basics. Okay. Let's look up, let's listen. Nobody got it right, which means nobody knows what's going on. So don't talk now, listen. You got it right, right? Oh no, you didn't. Look up. So we are asking from what value from minus infinity, that is to the leftmost, to C, if you integrate, the area will be 0.05. That is the question. Okay. First of all, just like you said, this is more than 0.5, so it should be to the right of 0. This is less than 0.5, so it should be to the left of 0. Agree? Okay. So if this is to the left of 0, okay. So this is like writing, to draw it here. Here is 0. So here is C, and this value here is 5%. Okay. So, but due to symmetry, you can write this portion here. If it is 5%, how much is this portion? This is 0.45, right? That is to the left of 0, the entire area is 0.5. So if this is 5%, then this area over here should be 45%. Do you agree? 45%. So it's like asking by 0 to C, f of z dz, f of z dz is 45%. What value of C will get you 45%? One point 1.645. Right? We just did that previously. 1 point C equals 1.645. But here's the final twist. Nobody cares about the C that appears here or at 1.645. It is this negative value that I'm asking you for. So the answer is minus 1.645. If you just decide that this is 45%, so I'm flip it to the other side. I'm going to figure out what value of what value will give me will give me 0.45. That is 1.645. But the answer is minus 1.645 because you are interested in the value that is to the left of 0. So this was the catch. Many students kind of missed that. So the answer you should be putting down is minus 1.645. Lot of people left out the negatives. Do you have a question? No? I mean, see, between minus 1.645 and plus 1.645, you get like 90% of the value. So to the right fringe, if I call this a fringe, to the right of this, that is 5%, this is 5%. So minus 1.645 is what contains 5% of the probability. Yeah.
Look at it as 95%, but it's on the other side of.
Yep. You have to use 50% as the median to decide whether it is located here or here. Simple idea. Yeah. Okay. Can I go on? Next part. So I mean, all this is getting recorded, so you can see back the solutions. So this is 1.645. This is minus 1.645. So what value of C will get us 50% such that minus 0.5 less than Z less than C is 50%. So you have the bell curve. Here is 0. Here is, let's say, minus 0.5. We are asking for what value of C will get you an area of 0.5. Should I draw the value of C to the left of 0 or to the right of 0? Sorry? To the left. So you are saying draw it like this. Sorry. You are saying draw it here. No? So the answer is intuitively, everybody agrees with me when I say here, let's say C is here. So that this area in the entirety is 50%. Okay. Why am I allowed to draw this here? Because if this is 50%, whatever is not shaded is also 50%. And you can look up what is the value for 0.5, that is 0 to 0.5. The value is only 0.1915. That is this area here. This area here is only 0.1915. That is only 19%. The remaining 30% have to be here. So the remaining, that is 0.5 minus 0.1915 has to be here. So which is 85. 14 minus 9 is 5. No. Sorry. 5, 85, 0, 40.85. 40.85? 30.85. Sorry. 30.85. So this portion here should be 30.85. So now look up your table and figure out what value of C will give you 30.85. Yeah, we can say 0.87. So the value of C which will give us 30.85 is 0.87. Point 87. With me so far? Anyone wants me to repeat or go over something again? Are we okay? Last question. Probability of Z greater than or equal to C being 33%. That is, if I erase some of this. Here is the bell curve. Here is 0. I'm asking for a value of C after which 33% of the area comes along. So should I draw C to the left or right of 0 first? Left. Should I draw C here? Is that what he's saying? Okay. So you do know that the right hand half contains 50% of the area, right? So if I draw C to the left, that will only make it at least more than 50%, which won't make sense. So what we should do is to draw C over here so that everything to the right of C is 33%, or everything to the left of C between 0 and C is 17%. So if it is 17%, what value of C will get you 17% of the area? 0.44. right? If you look up, 17% of the area is contained by, or is occurs at 0.44, or 0 to 0.44 contains 17% of the area. This can be tricky. I mean, if you don't pay attention. Okay, so what are the other things I want to highlight? All right, so I want you to look over mainly from fall 2023. If you see exam one had two modules. It had equation solving and linear equations. So both of which are in our current module 1 and 2. So you can try these examples. There is the solution here for you to check right there. Remember, in the quiz, you don't get to use Excel sheet. You have to do everything manually. So I might ask you first 3 or 4 iterations. Okay, so you have to compute the X value and keep computing the relative error, like we did in the quiz. So try these problems, bisection method. Here is Gauss-Seidel method. And then here is again, I think this is Newton-Raphson with one ugly physics-based equation that you have to solve. And again, Gauss elimination. I would also ask you to look at the final, because in the final I had questions from all the topics. I think what we saw was the final, wasn't it? Yeah. There are also questions on bisection method and equation solving that you can go through. Okay. And probability. Okay. So this sort of problem is also very much possible. We give you like a question with a problem statement with a mean, which is not like a small number, and then standard deviation, and then asking you what is the chance that the cost will exceed $15,000. So that's like asking what is the chance B will be more than 1.5, which ultimately the skill is in coming to this point. How do you convert a given problem into language based on the standard normal distribution? Once you do that, the rest of it is reading the table. Okay. You can also go back here and see fall 2019. In that semester also, I had lots of quizzes. So if you look at, say, quiz 6, I think that was involving statistics. This is a problem a typical problem in normal distribution. So if you have a grade distribution that is given like this, calculate how many A, B, C, D, and grades will be given per 100 students, and what should be the lower ranges so that approximately 40% of the class receive 40 B grade, something like that. So this is also something you should practice. I did tell you that I'll ask a confidence interval based question, but there is always the possibility I can work in the normal distribution into that problem. So don't skip anything. Okay. Any questions from your side? Okay. So for the homework 3 Monte Carlo simulation, here is the example that I want you to program. The question is given right here, the procedure is given, and the final output that you are expected to get is also provided to you so that you can cross-check your work against this. And this is due by October 30th. Okay. This handout is posted, yeah. And if you go at the end of the chapter problems, there are many problems on normal distribution and confidence interval. So please try some of those. Actually, if you look at problem 4.20, this is a very good question on Poisson distribution. So try looking at these as you practice. Okay, thank you.